Greetings! Oh, we got a fun one. This car made me angry. So angry. Let me tell you why. Ladies and gentlemen, I give you the 2006 Crosstrek. This has been a very fun diagnostics. So, let us talk about what's going on. And I hope we don't have, I'm hoping I don't have to do a voiceover due to the wind. I'm doing this outside from the shop because everybody has their music going right now. It's a little aggravating. So let's talk about what we have. Customer starts the car. Everything looks normal. Everything looks fine. Now let's go ahead and shift it into gear. I step on the brake. Okay, we're just going to step on the brake. And immediately, I got a transmission code with a flashing AT oil temp light. If we leave the car off for about 5-10 minutes, that code will go historical until we step on the brake again. Very interesting. So now we're going to look at what code we got. And we have in the TCM stored, we have the same code again and again and again. It is a P0801, reverse inhibit control circuit open or close. Looking at the freeze frame, engine speed was low, turbine speed, acceleration, our ATF temp was negative 58 degrees. That's important to note. Whenever we have open circuit conditions on sensors, we get weird things like that. We'll get extreme lows or we'll get an extreme high if it's shorted. It just depends on how the sensor is wired up in the computer. But those are things that you want to look out for when you're looking at freeze frame data. You want to look for these extreme measurements. This could be related to our open condition. And open might make the computer see negative 58 degrees Fahrenheit. Control module voltage has 0 volts. Okay, this is very interesting that it can set that code with those conditions. Let's go ahead and hook up a scan tool. Yeah. Okay, those are coming away. I want to see if I have a more current freeze frame to look at. Alright, so I'm going to go back into this. And let's see what's going on live. Each system, TCM. Okay, DTCs. Okay, same stuff there. I'm gonna go ahead and clear it out. I'm gonna see if I can't get some fresh freeze frame data to see what's going on. Okay, we have no flashing ATF light. Gotta step on the brake. There's my code. Now we got a current set condition. And good, that's what I want. I want 3 iterations of freeze frame. This is better. Okay, so the ATF is not related. I wanted to do that because in the other freeze frame, it showed that the control module voltage was 0. So obviously, if that sensor has no voltage going through it, or if the computer's unplugged, it's going to read neg 58. So let's not go down that rabbit hole. Can we see anything else on here? Do I have a brake light switch maybe? P range, reverse. So I'm not seeing anything. With freeze frame, the computer will snapshot what has happened in the last second and the last 1.5 seconds. Each column after the detection is supposed to represent a half a second. Okay, that's 500 milliseconds. 500 milliseconds, 1 whole second, 1.5 seconds. That's generally all we need to see for detecting criterias of what's going on. So what I was looking for in all 3 of these columns here is I was watching to see if there was a dropout. Is there a dropout? And I didn't find any dropouts. So if you're not too sure what your PID, your PID, is doing in freeze frame, then at least what you want to do is if you get 3 columns of freeze frame, you want to start looking for dropouts, because that dropout might be the breadcrumb trail you need to take you somewhere. So we're going to call this freeze frame a loss. Bummer. So let's see what's going on. What does a P0801 tell us with the OEM information? See here, continuously variable transmission diagnostics without the hybrid. Support code DTC P0801 reverse inhibit control circuit. Key word circuit. Those are very important when the people write the codes. I cannot stress that enough. Understand keywords like that. They're talking about a circuit. They're not talking about a sensor. We're not talking about a component. Not yet. We're just talking about a circuit. So, immediately at fault on recognition. So that means that the set criteria for this, everything has to be perfect. General description of a P0801. Okay. This is what I really like about trouble codes. Is the detecting criteria. What does it take to set a code? Outline of diagnosis. Detect the malfunction of shift lock solenoid or circuit. Okay, so now it's listing a component and it's listing a circuit still. Allergies. Judge as an NG, a no-go, if abnormal signal from the integrated unit is received, when bus off is not detected, and there is no trouble in CAN between the integrated unit. So means we're also looking at a CAN signal. Okay, enabling conditions, secondary parameters, malfunctions listed on the right column are not detected. Okay, those are network codes. Diagnostic method, if the duration of time while the following conditions are met is longer than the time indicated, judge as a no-go. So it says it needs to be looking at the shift lock solenoid circuit as an abnormal. Received from the BIU. Okay, we're hearing shift lock solenoid again, we're hearing BIU now. And time needed for diagnosis, 1 second. So this code takes 1 second to set. Cool. I like that. So let's do an all scan, see what's going on. Okay, there's our P0801 reverse inhibit control circuit open, and we have in the body control module a B1016. And if I remember, here we are. Whenever it says on a condition for a P0801 reverse inhibit control circuit, it says diagnose, follow the references and the diagnostic procedure for a B1016. Okay. So this is what the engineers wrote. And this is what the engineers wrote, and I'm going to tell you, you should always follow manufacturer flowcharts, and I'm also going to tell you, you should not follow manufacturer flowcharts. It is not the best advice to give. So what do I mean by that? What I mean is, I don't want you to skim through here and find something that says replace or if this broken. No, just I want you to understand what they want you to do. So in here it says turn the ignition on, keep the park range for approximately 5 seconds, read the DTC. Okay, it's asking you to monitor a malfunction. Again, we're doing a performance test of the solenoid. It says, do you still have a current 1016? Okay. So what is it doing in these tests is it's doing performance tests of the vehicle, and it's trying to help you out and save time so you don't have to go down rabbit holes, because if you get this, then these things must be good. Okay, now we're getting into the stuff that we hate, the resistance checks. Okay, so it says go from connector B116 pin 4 to chassis ground. Okay, so that's this connector right here, pin 4. It says it goes go from here to ground. Is resistance less than, wait, okay. Is the resistance less than 10 ohms? Yeah. Okay, it's checking for an open circuit. Okay. Measure the resistance of the shift lock solenoids. Solenoids have resistances. Has a natural resistance due to the wire that they use and the way that they wrap it around. Okay, is the resistance reading off? Okay, now it says it wants us to hook up a power and a ground to the solenoid and see if we can make it work. Does it go in and out? So we're doing function checks here. But when I read through this, I didn't see anything too relevant that I didn't already know. All I do appreciate is that I have this beautiful simplified circuit diagram here. No wire colors, of course, but simplified. So this is what we want to see. And this is what I've observed. Turn the car on. This is the solenoid in question. It is plugged in, and when I step on the brake, it doesn't move. Okay, it should be going in and out, in and out, in and out. What should be happening is when I step on the brake pedal, it should go in, out, in, out. Okay, and it's not doing that. That's all the movement I'm looking for. What I want to move forward with my test is, one, do I got a bad ground? I could test that with my ohm meter really quick. I could see if I got a bad ground. Bad ground might cause this. Second thing I want to do is I want to look at these legs right here, and I want to make sure that they are good to go. So it looks like the BIU is going to be controlling the power, and it's going to put out power to this coil which is going to energize the switch. I can test that really simple. Okay, so let's go to pin 3. Pin 3 of that connector. Okay, we're going to be using my pocket meter here. I don't get to use her that much. The back probe. Ah! It's back probe into 3. Stay. And a ground should be pin 4. Yeah. Start the car. Nothing. I'm getting no power. Barely anything, actually. 0.08 volts. That's not enough to energize that solenoid, obviously. Okay, so looking at my circuit, my simplified diagram right here, I've identified that on this pin right here, I don't have my power. I'm obviously going to need some sort of power, whether it's 12 volts or 5 volts, to make that coil work. Let's go to the I/O chart and see what's going on. Here's the input-output chart, I/O chart, for the BIU. And I highlighted where I want to go to. Oh no, where'd it go? I lost it. Let's find it again. Left. B5. Perfect. Okay, shift lock solenoid B5 says we should have less than 5 volts to 8 volts or more. So basic square wave that I'm looking at, and this column up here reads ignition switch on, engine off. So we can test this without the engine on. So at rest I should have less than 1.5 volts, which I did, but stepping on it to get the other condition I should have 8 volts or more. So obviously this is a 12 volt circuit. So I'm not getting my 12 volts out. Let's go ahead and abandon the simplified wiring diagram and let's go find a more complete wiring diagram and see what's going on. Shift lock. Hey, look at that. Shift lock control system has its own circuit diagram. I can work with that. So now I just want to go over some components that I see here. I like to identify. So I like when I get one of these diagrams, I don't want to jump to anything right away, but I like to just identify what I see. I have all my power up top, and I got power coming from the cabin, the engine bay, the cabin, the engine bay, the cabin, the cabin. All right. There's a hidden fuse right here, okay, and that's a fuse bank. So that's a hidden fuse bank that's inside the dash. It's not available to the customer. That's good to note. Let's look at my components. The key warning switch, stop light and brake switch. Here's my BIU, body integrated unit. Some CAN wires, key lock solenoid, shift lock solenoid, P range switch. Hey, Alright, good. Okay, there's a lot of shared ground here. So my key lock solenoid shares a ground with this, and my BIU uses a ground from there. That's good to know. You can get all kinds of weird problems if you got a bad ground going to a computer. Computers traditionally use more than one ground point. Let's do the simple thing right now. Let's just check our fuses. The first thing you should do in anything with a chart. I'm in the shift lock control system. I have a shift lock problem. Here's all the identified fuses. Let's go ahead and check those fuses. So we're under the hood right now, and we're checking out one of our main bus fuses. And there it is, right there. We got a blown fuse, and that fuse is under the hazard circuit. Let's put a good fuse in. Would you look at that? The solenoid works. Jeez. Let's see what my multimeter reads now. Awesome. There we go. You step on the brake, we get B+ coming through the solenoid. Oh, that's annoying. So the fuse under the fuse box labeled for the hazard switch, this thing didn't work. Man, this is where I kicked myself. So I've been sweating on this for about an hour and a half. Okay? And I was... So this is why I want to talk to you about this diagnostic process. Could I have done other things to catch this faster? Okay? Because I've been on this problem for at least an hour and a half. At least an hour and a half. And I've had some frustration with it. I've gone and I've done another job and I come back and I worked on this. But I've been kind of like, this is funny. So we can't take the fuse labeling under the box at face value. Obviously, that power got shared to the BIU, according to our circuit. This is what I kicked my butt. I was so sure of my ability to diagnose that I forgot one of the simplest things that I can do, and that is a basic multi-point inspection. If I had gotten into the car and I had been like, do my headlights work? Do my turn flashers work? Do my brake lights work? Does my hazard work? That would have stood out. I would have been like, whoa, hazard light, is it related? I have been in those situations. Okay? I have been in situations where people say, hey, my car don't turn on. And it's been diagnosed by two different people and they're looking at it. And thankfully, I had the sense enough to calm down and go, let me check everything else in the car and make sure it's working. The windows worked, but I noticed that the spot lamps didn't work. Okay? Oh, well, that's an easy circuit, and I found an open fuse in the spot lamp, and when I replaced the spot lamp fuse, the car turned on. It's weird. And you have to watch out for that. So I was a victim of my own best practices. I was a victim of not doing my own best practices. And that is, inspect the car every time you get it. Just don't jump into it. Because this fuse right here, MB28, That's what we replaced. Okay, this is the MB28 circuit right here. There's my 15 amp fuse. And I'm going to come down here. I want to see. There we are. MB28 supplies power to the key warning switch, the turn signal and hazard unit, and the body integrated unit. So the BIU is tapping into that 12 volts to get that solenoid to power up. I also said my key warning switch too. Sure enough, the key warning switch. Okay, here's power coming through. Power is shared there. I think it's a stick. So we got power here, and if I backtrack this, there's more power there. Interesting. B555. It's a 2-pin connector. So this is not easy enough for me to decipher why we got power on both sides and what's going on. We got some option wiring here. OP. What's going on? Without push button start. Okay, alright. So I can ignore that light. That helps. So power comes through here. I close the circuit. And the BIU has a designated ground. Did we have a key warning light? Now I want to know. Where's the customer keys at? There they go. Yeah, there's a ding. Okay, so I just get the regular dinging prop when I power the vehicle up. Let's see what happens if I open the door with the key in it. I don't get anything. Okay, let's replace that fuse. Hey, there it is. There's the ding. Another observation that I missed. And I've had this door open with the diag the entire time. I was also wearing earplugs too. Sorry, it's just, you know, everyone's playing loud music. That's why I don't like loud garages. I don't like people blasting out their music. This could have been another clue for me that I missed. Yeah, I missed this, but I'm pretty sure I would have picked up on that door chime. So if you're doing diagnostics in a noisy area, get out of the noisy area, take out your damn earplugs and listen. Oh, pissed me off.